Hello students, and welcome to the final video of this calculus lesson. In this video, we're going to go through very rapidly our final page, the final 3 problems of related rates. That doesn't mean related rates are going to be over, because they're a very important concept to understand and figure out, and it really ties all your calculus knowledge thus far together. So make sure you get your related rates down, and let's get started. All right, so in our first problem, an airplane's flying at an altitude of 5 miles. Okay, so altitude of 5 miles passes directly over a radar antenna. When the plane is 10 miles past the antenna, the rate at which the distance between the antenna and the plane is changing is 240 miles per hour. What is the speed of the plane? Okay, let's see. Here's the radar antenna. We'll put that right there. And then we've got the height here. This is going to be 5 miles. And that's going to remain constant, so that's going to be y. Okay, and then we've got this x value here for our plane, so our plane is right there. When the plane is 10 miles past the antenna, so this is 10, but that could change in the next instant, so that is not remaining constant. The rate at which the distance between the antenna and the plane is changing is 240 miles per hour. So between the radar and the plane is 240 miles per hour. So z, or dz dt, is going to be 240 miles per hour. All right. And we want to know what is the speed of the plane. That's going to be dx dt, because we measure it in knots. That's going to be the horizontal distance. What is the speed of the plane, dx dt? All right. So what I'm going to do real quick is, I know I'm going to be using, okay, what relates all those 3 things is the triangle. So I'm thinking Pythagorean theorem, and that's going to be x squared plus y squared equals z squared. All right. I'm going to substitute in what is, actually what I want to do is I want to figure out what z is going to be first. Okay. So x is going to be 100. Because that's 10 squared, and then y is going to be 25 because that's 5 squared, and so then z squared. All right, so I'm going to take the square root of 125 to get z there, and that is going to be, and now that is in miles. Let me just make a note there that that is in miles. So that's going to help me figure out, after I differentiate, what the z value is going to be, and you're going to see that I am going to need that in a second. Of course, you could have done any of that work after we had needed it later, but let's go with the x squared plus y squared. Actually, we know y is going to remain constant, so let's go x squared plus 5 squared equals z squared, and let's differentiate that. All right, because we want to figure out dx dt, and that's only going to come from differentiating that Pythagorean theorem. So x squared, that's going to be 2x dx dt. And then 5 squared, that's going to be 0, so plus 0, equals z squared, so that's going to be 2z dz dt. All right, and we are given everything, we have found everything in order to figure out what is dx dt. So x is 10 miles, so I'm going to go 2 times 10 miles, so that's going to be 20 miles, dx dt, equals 2 times z, which we just found was square root of 125, so let's just go 2 square root of 125 of feet, times dz dt, which is 240. So then that's going to be 240, okay, miles right there, and so then this is miles per hour. All right, so I'm going to simplify the right side of the equation first so we can isolate dx dt here in a second. And so 2 times 240, that's going to be 480 times square root of 125, and I get miles squared, square miles per hour. All right, now what I'm going to do is divide by 20 miles. All right, so that divides out there, and then the miles are gonna, one of those is gonna divide out, and so we're gonna be left with the speed of the plane, dx dt, is gonna be 480 divided by 20, which is 24 times the square root of 125, and I'm just gonna leave it as an exact answer here, 24 times the square root of 125, and then miles over hours, so miles per hour. So we know if we were to multiply that out, we would know the exact speed, or at least round it to a certain decimal value of the plane. I wonder what that decimal value is. I'll leave that to you guys to figure out. Now we're looking at the radius of a sphere that is increasing at a rate of 2 inches per minute. So the radius of a sphere, the radius is at a rate, so that's going to be dr dt, and it's going to be positive. Now we want to find the rate of change of the surface area, so of the sphere when the radius, when r is 6 inches. Rate of change of the surface area, so that's going to be, we want to find dA dt. All right, so what relates a sphere, because we know the shape, that's going to be area and radius. Okay, what's that formula? So go look at that formula. That's going to be A equals 4 pi r squared. And we want to take that derivative. All right, so let's take that derivative. That's going to be dA dt equals 8 pi r and then dr dt. Okay. And then we want to just make our substitutions. It's nice that dA dt is already isolated. So dA dt equals 8 pi r, which is 6 inches, so 6 inches right there. Dr dt, which is 2 inches per minute. Okay. And let's figure out that rate. So dA dt equals 8 times 2 times 6, which is going to get me 96 pi square inches per minute. And again, that's why I keep the units with it the entire time, because it makes it so much easier to analyze the units as I'm moving forward, because I have it all to multiply as I go forward. So we have some sort of balloon or some sort of ball with that spherical shape that we're blowing up. And we're blowing it up. The radius is changing at a rate of 2 inches per minute. So we know exactly how much that surface area of the balloon, because it's shriveled up, right? It's really small, but as it gets larger and larger, the surface area of the entire thing also expands as well. So we know that rate at certain points. And now we want to look at just this final problem. A spherical balloon is expanding at a rate of 60 pi cubic inches per second. Okay, so let's see what we know. So we know it's a sphere. We know we're expanding, so that's going to be positive. The rate of cubic inches, so that's going to be volume, and it's a rate, so that's going to be dV dt. And then how fast is the surface area of the balloon expanding when the radius of the balloon? So the radius, so that's going to be r, is 4 inches. And how fast is the surface area changing? So we want to find dA dt. Okay, so you might be thinking, how are volume and area related here? Well, let's just kind of start with the dV dt and see what we can do from there. This might be something where we're going to solve for other variables and then substitute in to another function later. Okay, so let's get volume equals 4/3 pi r cubed. And if I make substitutions, or if I take this derivative, I have dV dt equals, bring that 3 down, so that's going to be 4 pi r squared dr dt. All right, and I have values I can substitute here. So dV dt, and I have values I can substitute here. So dV dt was 60 pi cubic inches per second, and that's going to be 4 pi r squared, which is 4, so 4 inches squared, and then we want to figure out dr dt. Okay, so we have a variable we can solve here, and what I'm thinking is I'm going to use the surface area formula, and I'll be able to use the dr dt that I get from this volume in that surface area derivative later. All right, so let's figure out what dr dt is. So I'm going to get 4 squared, which is 16, times 4 pi, which is 64 pi square inches dr dt equals 60 pi cubic inches per second. All right, let's solve for dr dt. So that's going to be dividing by 64 pi square inches. All that's going to divide out. And same thing over here, 64 pi square inches. So 3 minus 2, that's going to get me inches over seconds. So 60, the pi's are gone because that's they divide out. That's going to be 1. So 60 over 64, that comes out. That simplifies to be 15 over 16 inches per second equals dr dt. So let's figure out why that is probably going to be important, because let's relate area of a sphere, surface area of a sphere. So I'm going to have area equals 4 pi r squared. All right, so then if I take that derivative, I'm going to have dA dt, which is what I want to solve for. Bring the 2 down, so I'm going to get 8 pi r dr dt. And now that I have the r is going to be 4, but before I didn't have dr dt, okay? And now I do have dr dt. So you could have done this in either order, and then noticed here that you didn't have dr dt, and then actually just come over and solve this part out second. So it doesn't really matter the order, but you will need this at a certain point. So I just try to do some forward planning and be like, okay, what do I need? What can I solve for now? And then use later. So dA dt is what I want to solve for. So dA dt equals 8 pi r, which is 4 inches. So 4 inches. And then dr dt is 15 over 16 inches per second. And I think I have enough I can go off of. All right, so 8 over 16, or 8 times 4, let me see. 8 times 4 is 32. 32 over 16 is 2, and then I could go 2 times 15, which is going to get me 30 pi, which is a very, very clean answer if you think about it in terms of everything. Inches squared, because inches times inches over seconds. So square inches per second, 30 pi. We know that the surface area of this balloon as it expands is expanding at a rate of 30 pi square inches per second. So if we were to stop it exactly at that moment in time when the radius of the balloon was 4 inches, then we'd be able to see exactly what that surface area was. So 3 very quick, these are probably going to be more like, notice here that they didn't really require too much thought, too much analysis, like the last video in part 6, where it was 3 different parts of essentially the same problem, using some of the values from before. So that last video is more like a free response question, whereas this one is 3 multiple choice questions, and you would have multiple choices to go and find the different answers that you would need. All right. So that's why these kind of went a little bit quicker than the last one, where everything kind of seemed interconnected. Of course, if you do need help with any of these 3 problems, please reach out to me. I'm Mr. Hernandez, and this was Mr. Hernandez Teaches.